Hi everyone, welcome back to Padhai Logic. If you are a student looking for your semester 6 syllabus, wondering how to crack data analytics and visualization without joining in technical jargons, you are in the exact right place. Today we are breaking down Unit 1 completely. We will go through absolute basics like what raw data is, all the way to building good analytic model and understanding the real world data sources. Make sure to grab your notepad, hit that subscribe button, and let's get your concept crystal clear. Let's begin with discussing what the PYQ radar says. So there are top 14 questions which was continuously asked in our last two PYQs. So we'll be discussing about what data analytic is, what is the analytical process model that we follow in the process, what are the various profiles that are used in data analytics, how we collect the data, various sources of data collection, and we'll also discuss about data standardization, sampling, distribution, different type, what is the difference between sample and population, right? And we'll also understand what is outlier detection and what are the methods which are used to overcome those outlier in the data set. We'll be also focusing on the population distribution and what is the random sampling, what are the types of sampling distribution, and specifically also what is different types of random samplings. So let's get to it. The very first thing we need to know is the basic nomenclature. What are the basic terminologies which we need to be aware of when we use it in our analysis process? So if we talk about analytics, it is not just about numbers, it is the systematic use of data, right? So analytics refers to systematic use of data, of statistical analysis, of computational techniques. For what? To discover the patterns, to gain insights that what our data is trying to tell us, and support the decision making, that according to the data what decision should we take to help our business, right? So to understand the analytics properly, we need to know these basic terms. If we talk about data, data is just a raw, unorganized facts without any context. For example, you see number 450, you see number 500. So this is just a random data, right? Data can be structured, unstructured, and semi-structured. Structured data would be when we organize the data in tables. When you see databases, that is the structured data. Then we have unstructured data, which is like images, videos, social media posts, emails, etc. And we also have semi-structured data like JSON files and XML files, etc. Then what is information, right? Information is when data has been processed, data has been structured or given a context to something, right? For example, you just see the number 450, but information would be that 450 items had been sold for this month and which led to spike in the sales. So this is what information is. We get to know the context that what our data is trying to tell, right? And then comes the data set. All right, so this is a structured collection of data. So typically when you see there is a data in the form of rows and column, that is known as data set. So I'll give you a real world example for these three terms. Think of an Excel sheet for a college fest. So a single random column number like 101, 102, 103, for example, we have these values. It is just data. So once you add the label to the column, so for example, you add label like student ID, and then there is a column 101, 102, 103. What is this? This is what you call as data set, right? So there is a Excel sheet containing name, ID, department. This is your data set because it has rows, it has multiple rows, it has column, it has attribute, right? And then we figure out that there is a column name student ID, right? So we calculate how many number of students were there. So we were able to understand that there were total 500 students that registered in that particular fest. So this 500 student information, that these much students were registered, is information. I hope you understood these three terms. Now we'll move forward and discuss about variable. What is variable? So a characteristic that changes value. Okay. So if there is something, it is in the name, that vary. Vary means that changes value. For example, there is price. Price is changed according to the environment, according to the needs, inflation. Then there is time. Time varies all the time, right? And then there are two types of variable, independent and dependent. So independent variable influences the outcome. All right, independent variable influences outcome like price, time, right? And there are dependent variable, that is the outcome being observed. So because of the price, sales drop. So sales is dependent on the price. So sales is the dependent variable, right? So this is how we observe what is dependent and independent variable based on the characteristics, right? Then we have matrices. You might have heard this term a lot. So matrices is a quantifiable measure used to track the performance. Okay, so for example, we have revenue growth, customer churn rate, how many customers are actually leaving us, right? What is the loyalty performance? These are the matrices. All right, and then we have KPI. KPIs are very important term to understand according to the business goals. So when you're working for a firm, they measure their performance using KPIs. KPIs stand for key performance indicators, right? So they are the most critical matrices. So we talk about matrices, there are multiple matrices which are used to measure the performance, but KPI are the critical ones, very important ones, which directly align with the core business goals, right? So there can be 100 of matrices which is used by a company, but there might be few KPIs which are actually measuring the business goals performance, right? Which are actually showing us the numbers we want to see, the trends we want to see. So for example, you run an e-commerce store, so the variables are the product price, right, and time of the day. Okay, these are the variable, product price and time. And your metric is the total number of website visitors. But your KPI would be conversion rate. What is the conversion rate? What is the net profit margin? Right? So these are the ultimate numbers that tell you if your business is surviving or thriving, right? Next, we move forward and discuss about what is descriptive statistics. So you might have already know what statistic is. We'll talk about descriptive. So this term means that we are summarizing the historical data. Okay, we summarize the data using what? Using common measures like mean, median, mode, range, etc. And then we have inferential statistic, which draws conclusion about large population based on the smaller sample. All right, so this is also known, so example of inferential statistics like hypothesis testing, confidence interval, regression analysis. So this is what we do when we have a lot of data, but we take just a sample and draw a conclusion that this would what it means, like probability, right? Then we have data mining. All right, so if we talk about data mining, it is about uncovering hidden patterns. So we discussed about data mining in detail in data warehouse and data mining subject. So if you have not watched those videos, kindly go back to our channel. There is a complete playlist which has masterclass for all the units, and we have covered data mining in that. Alright, so data mining is about uncovering hidden patterns, cluster and association in the massive data. And then we have data visualization. When we have all the information with us, those are just numbers. We have to graphically present all those things. So that graphical representation to make the data beautiful, presentable, is data visualization. So we are using graphs like bar chart, line chart, dashboards. Dashboards are used like Power BI dashboard, you might be aware of those till now. So we are using that to actually display our data in such a visually representable format that it looks beautiful as well as insightful. Now let's quickly discuss about what is the hierarchy. So there is a 3-tier pyramid. All right. So it is telling us that first we have data. Okay. So data is for example, it is a raw fact and figures. So for example, we have a data of sensor. Sensor records that there is 40 degrees data coming out of the sensor. So then comes the information. So from that 40 degrees, we discovered that the weather dashboard says that local temperature is 40 degrees. Then comes the knowledge. So based on the history, 40 degrees Celsius in June means severe heat wave is hitting the city. This is what knowledge is. So knowledge is derived from the information, right? So information said that the weather dashboard displayed the local temperature, right? So knowledge was derived from information stating that based on the history, this much temperature means there is severe heat wave. And then last we have wisdom. So let's stay indoors and drink plenty of water to avoid heat stroke. This is what wisdom is. So we are providing application of knowledge to make decisions. So when we make decision, like we made this, that we stay indoors and drink plenty of water, this is what wisdom is. Based on the level of insight provided, analytics is classified into 4 different types. So we have 4 types of analytics. First is descriptive. Like I previously told you about this term, that descriptive asks a question that what happened. Right, so this is a question asked that what happened. So we are analyzing the past historical data. Then comes the diagnostic analytics, in which we ask the question that why it happened. All right, and then there is predictive analytics, which talks about what will happen now. Okay, and then we have prescripted, what should be done. So we are talking about past, we are talking about the reason why it happened in past, then we talk about what will happen in future based on that, and then what should be done for that thing to happen in the future. So these are the 4 types of analytics. Let's discuss them in detail. So descriptive analytics focuses purely on summarizing the historical data, right? So it does not look forward or explain why, it simply states the facts. All right, it simply states the fact. So for example, a supermarket analyzes total sales of the last month and number of customers per day. So we are just analyzing the data, right? So we use technique like mean, median, mode, percentage and total, and frequency distribution. Next comes the diagnostic analytics. All right, this takes a step deeper to identify anomalies and drill down into the data to discover the root causes and correlation. So you see, for example, there is a sudden 20% drop in the sales. So you look deeper and find out the key competitor launched. That you found out that a key competitor launched 50% discount. All right, that is why you had 20% drop in the sale in the exact week. All right, so this was causing your customer footfall to the plunge. So this is why we use diagnostic analysis to identify why that thing happened. Then we have predictive analytics, which talk about what will happen, right? So we use historical patterns, statistical models, and machine learning to forecast the future trends and probability. For example, predicting next month's sale and forecasting that customer demand for jackets will spike 40% during the upcoming winter season. So we are forecasting and we are predicting that what will be the sales, right? So in such scenario, we are using predictive analytics. So for example, so what are the techniques used in predictive analytics? They are regression analysis, time series forecasting, and sampling distribution. Lastly, we have prescriptive analytics. So it asks the question that what should we do? So this is the most advanced level of analytics, and it suggests specific actions and optimized choices based on the predictive insights to maximize the positive outcomes. So for example, there is a automated retail inventory system that says that based on the winter forecast, automatically order 500 extra jackets for today and offer 10% discount on summer t-shirts to clear out the old stock. So based on what we described in predictive analytics, right, that there is a demand, that the customer demand for jacket will spike 40%. So according to that, what should we do? This is what analyzed by prescriptive analytics, and it says that order extra 500 jackets today and offer 10% discount on summer clothes to clear out the stock. I hope you understood how these four kind of analytics work. Alright guys, so when you're working as a data professional, you don't just jump into coding or writing SQL queries. You follow a structured step-by-step process to convert the raw data into gold. So that structured step-by-step process is known as analytic process model. So it refers to structured step-by-step framework which guide us how the raw data is transferred into useful insight for decision making. Alright, so it ensures that there is a systematic approach to how we solve the problem. It is a methodology which concludes sequence of tasks which we take from understanding the business problem to collecting the relevant data, and then we apply analytical techniques to interpret the results and the actionable insight. Right. So the very first step is to understand the business problem and requirement. So when you know that there is a problem, you first read about the problem, not just jump into the solution. Right. So defining exactly what problem need is what the step one is. It identify the business objective and determine what type, what amount, what time of period, whatever is required, and how to solve the problem. Alright. For example, our problem is that why are users uninstalling our app? So first you understand this problem, you then do data requirement. Alright, that what kind of data would be required for solving such problem and how are we going to solve that. Then the second step is data source identification. So locating where the necessary data lives. Is it in customer relationship management? Is it in databases? Is it in social media or external third party server? Where is our data? So that is the second step where we identify our data source. Then we quickly move to the third step, which is data selection and data mining. Alright, so in this we are selecting the required data. We are pulling only the relevant data set and ignoring the noise that we don't require. Then comes data cleaning. So when we remove the missing values, correct duplicates and eliminate the outliers to make the data completely reliable, that is what data cleaning is. After cleaning the data, we move forward and do data transformation. So after cleaning the data, we are converting the raw data into analysis ready format. So before we just clean the data, we just remove all the dirt, and now we'll do the formatting. Now we'll make it in a form that we are able to do analysis easily. Like we are using normalization, we are transforming the text data into numerical data and whatever our requirement is, right? And after the data transformation, we move to analytics and process discovery. Alright, so here we apply the analytics. We need to apply descriptive analytics, predictive, diagnostic, depends on what our problem is. So based on that, we apply the algorithms and uncover all the insights which we get from the data. And lastly, we do interpretation, evaluation and application. So testing the results against business goals and implementing them into real world workflow is the actual gist of why we use this analytical process model. right? So this analytical process model is the backbone of this entire process. All right, so we use analytical thinking. It involves breaking down highly complex, messy business problem into simple, singular, systematic, logical part. All right, so analytical thinking is deeply process driven. It relies strictly on the fact over instinct and the result in informed decision. All right, so we need to ensure that we are using our analytical thinking in the entire process of analytical process model. If we talk about data analysts, they don't just work in tech companies. So let's look at how different industries leverage data to survive, right? So first we should know who data analyst is. So data analyst is a professional who collects, clean, analyzes the data, then interpret it to help the organization make better decision based on the data, right? So they convert this raw data, messy data, into something gold, into something the companies can utilize to make better decision, to earn more profit, to be more reliable in the environment, right? So what are the various fields? First we have marketing analytics. So marketing analytics is focused on customer segmentation, where we are dividing the customer based on the distinct group, based on characteristic, based on behaviors. So we are grouping customers, right? For example, we are grouping the customer based on who are the high spenders and who are the bargain hunters, and then we create the discount strategy accordingly, right? Then we also use it for campaign performance. We are tracking the click through rates and conversion to see if an Instagram ad campaign was worth the money or not. Should we spend it more on it, or should we switch our strategy, right? And then we also use it for ROI analysis. ROI stands for return on investment. So we'll be calculating that do we get that return on the spend, on the ad spend which we did, and we calculate the financial efficiency using this data. So you see, data is like a gold mine. You have to search the gold, which is the insight from the data, which helps our organization to actually survive and thrive in the business, right? And next we have financial analytics. So in financial analytics, data analysis work in a form of risk management. We use stress testing and historical trends to predict if there were credit card defaults, or there was something like if there was cyber attack or not. So we are predicting any kind of risk management using the data. Then we have budgeting and forecasting. So in budgeting and forecasting, data analysts are managing cash flow and estimating company revenue for the next fiscal year. And we also have fraud detection, in which data analysts are spotting any unusual spikes or geographical anomalies, like for example in banking transaction, if there is any kind of fraud happening, using the machine learning algorithms we perform the fraud detection as well. If we talk about in the department of HR analytics, so HR is human resource. In HR, data analytics are widely used in tracking the employee performance. So we are tracking the KPIs, key performance indicator, to identify who are the top performing in our team members, right? So we fairly identify it using the KPIs. Then we also use it in talent acquisition. While analyzing the applicant, we track the data and find out which hiring channel bring in the longest retaining employee, and then we utilize that channel more. Alright guys, now we'll discuss about what are the key requirements for building a good analytical model. So a analytical model's Python script is what matters to coders more, but a model is only useful if it satisfies these 7 critical pillars which we are discussing right now. So the very first requirement is business relevance. So this is the primary requirement. So our solution must align completely with the business objective and solve a real world problem. All right, so it is very important that the requirement should be aligned with the business objective. So for example, the objective of business is increasing the profit, so our requirement should state that clearly. So if you see, for example, there is a churn prediction model. So churn, it tells that how many people are going to leave your loyalty. All right, so if there was a churn prediction model, and it is only valuable if it target customer before they leave, allowing the company to retain them. All right, so this is how we were able to target that. All right, these customers, right, these customers are trying to leave, so we immediately provide them discount strategy to retain them so that they are not leaving the company. So our company's objective was to increase the customer. So this requirement, this solution is aligning with our business, so it has business relevance. That is how you solve a real world problem. Second, we have statistical performance. All right, so statistical performance refers to how accurate and reliable your analytical model be. So our analytical model must be highly accurate. It should avoid overfitting. That means that working well on training data but failing on a new data. So that it should be avoided, right? So for example, statistical performance is measured using matrices like accuracy, precision, recall. So these are the matrices we use to measure statistical performance and see if our data is actually accurate or not. Third requirement is interpretability. So business managers must easily understand how the model make decision. All right, so there should be easy explanation to it. So business users and managers, they should understand that how the model works, how a particular decision or prediction was made. So there should be an interpretation easily occurring in our model, right? And then there is a fourth requirement, which is justifiability. So the model's logic must be logical, unbiased, it should be fair and legally defensible. All right, so decision must be, or for example, there are few decisions that has to be made according to your organization. So decision must be audited to ensure that there is fairness across genders, across races and income levels, so that you are able to justify your model's logic, that it is not unfair, it is not unbiased, and whatever it is predicting is accurate. Next requirement is that our model should be operationally efficient. So it must run quickly, consume minimal time and resources, and deploy easily. For example, a real-time credit card fraud detection model. So it must process the transaction in milliseconds to block the fraud instantly, so that there cannot be any fraud happening. All right, so this is how you need to ensure that there is an operational efficiency. Then comes the sixth requirement, which is about economic feasibility and cost effectiveness. So the financial benefits gained from the model must outweigh the cost of data collection, infrastructure and staff. Basically, there should be high ROI. Return on investment should be high. So you need to make sure that your model is economically feasible. For example, if a complex model with 92% accuracy cost us $100,000, all right, so to maintain, but a simple model with 90% accuracy cost us $5,000. So choose the simpler one. So why would an organization pay so much for just 2%? Right, so this is why it is very important to be economically feasible and cost effective. The very last requirement is regularity and legal compliance. So our model must fully strictly comply with the local and global privacy laws. So we need to ensure compliance with GDPR, we need to perform it for HIPAA and the IT Act, right? So these are very important to ensure that our data is handled privately and secure, that our data handling and user consent is taken. So our model must have the regular compliance so that if there is any issue arising, we have the support. Alright, so I hope you understood what are the requirements to create a good analytical model. Guys, when we see data in a textbook or in a clearly defined data, you see that it is clean and it is perfect. But if we talk about real life, implementing data analytics is like a battlefield. So here are the 5 major challenges that you face. The very first challenge is data silos. It is the isolated pockets of data locked away inside a individual department that do not talk to each other. So what happened, we gain incomplete insight because there is few data which is hidden. We don't know about that data, so obviously our insight would be affected. For example, marketing doesn't know about what sale is doing, which is leading to a fragmented view of customers. So we are just viewing the perspective of marketing, but we don't have any information about sales, right? So how can we ensure? So we can implement a centralized data warehouse where we store all the data, cross department data sharing, so that we are able to have a unified view of the data set. Then there is a second major issue, that is about lack of skilled professional. Since there is a huge talent gap for experts who understand both complex mathematic programming and core business strategy, so there is a problem in uh, delayed in implementation. There is optimal use of sub analytics tools are not happening. There is missed opportunity for data driven decision making, and this is leading to an actual serious problem because we are not able to identify the gist of the problem. So what is the solution? We invest in the training programs, we encourage professional development programs, and we also consider a collaboration with further institutions as well, right? And also we use good tools, and we provide good training of collaboration within the team to identify the gap and fill it. Then we have the concern of lack of privacy. So balancing data collection for analytical depth with strict user privacy regulation is very critical. Alright, so if we are using the sensitive data of the users, it is very critical to ensure that there is cyber security maintained. So for example, if you are using the sensitive data and there is a hacker which hacks your data set and takes away all the sensitive information, then you are at fault. Alright, so it is very important to establish clear ethical guidance on how to use the data and what are the security measures which would be implemented. Next, we have model bias and fairness. So if you see that if historical training data which we are using, it contains human biases, that humans have added the wrong values, so the analytical model will learn the same thing, it will automate the same thing, and there these biases would be exactly have in our model, right? So this discriminatory outcomes would lead to incompetent results, right? So there will be biased result. To address this bias, we should always perform audits, that if there is bias or not, and we should involve diverse team in the development of and the validation process. So there should be diverse team so that we have the perspective of every particular department, right? So it is very important that a model is fair. And the last issue is continuous learning and adaptation. So see, there is high rapidly evolving analytical technology, methodology, and consumer trends. They are exceptionally changing fast, and it is very hard to keep track of every technology, right? But if we are not keeping track of everything, our models would quickly become obsolete and inaccurate. Therefore, it is very important to encourage a learning culture, invest in training programs, and stay updating on emerging technologies. Let's quickly discuss about what are the data collection sources. So data sources provide the foundational truth for analysis. Their reliability, diversity and completeness directly dictate whether your business strategy succeed or fail in the dynamic landscape. Alright, so what are the basic types of data collection? We can do it through surveys and questionnaires. So we can have a structured method of gathering the information directly from the individuals or group, right? So for example, for customer satisfaction we use surveys, and for employee feedback we use questionnaires, asking them few questions to dynamically know what is actually how our organization is working. So then we also have sensors and IoT devices which capture the real time data from the physical world. Alright, we also have social media and web scraping, where we are using social media platform as our data sources and web scraping tool to extract the unstructured data from online sources like from Twitter feed, from Facebook post, from web articles. And we also have transactional data, which involves recording in interactions and transaction within the system. So you see, we have sales transaction of an organization, that is the transactional data, and we have financial transaction of a retail store, right? So that is come under transactional data. So these were the data collection sources. So let's quickly have a look on what are the types of data sources. First, based on the origin of the data, it is divided into two parts. First is primary and secondary. So primary data is the first hand data that is collected by the analyst for a specific purpose. So it is fresh, it is highly accurate and custom tailored, but at the same time it is easy, it is costly, and it is time consuming as well, right? So custom surveys, direct focus groups can be time consuming, whereas we have secondary data where there is a pre-existing data, so data already had been collected by someone else for a different purpose, so you're using that kind of data, right? So it is easily available, it is less expensive than the primary data set, and it is low cost, but it might be outdated or it might not perfectly match for your research goal. For example, there are government census report, there are industry research papers which can act as a data set for your own model. Alright, next, based on the structure of the data, it is divided into three parts: structured data, unstructured data, and semi-structured data. So structured data is organized, it is highly organized and clean data set fitting perfectly into the rigid rows and columns. So it is the structured data, right? So it is easy to store, right? And it uses rows and column, and it follows a predefined schema. So whatever the labels are, we are only following that. And we mostly use, for example, relational databases like SQL, Excel sheets, or their payroll tables, etc. Then comes the semi-structured data, which doesn't fit into the standard tables, right? It contains tags, markers, hierarchies to separate the data fields. For example, there are JSON files, XML files, the log files. So these are semi-structured, right? And you see they are flexible and they're easy to process than unstructured data. And then we have unstructured data which has no predefined format, so they are completely messy, completely unorganized data with no format. So it constitutes roughly 80% of the world's data and require advanced tool like NLP, right, AI to process. For example, we have videos, audios, PDFs, and raw social media posts. And if we talk about based on the time, we divide the data type into three different types. We have historical, real time, and streaming. So historical data are the data which are collected and stored over the past time period to perform trend analysis and forecasting, right? So it is used for trend analysis and forecasting for performance evolution as well. For example, past sales record or previous financial year data, and we are analyzing that. We also have real-time data, which is the data that is collected, processed, and analyzed instantly as event occur. For example, there is live stock prices, or there is immediate online banking transaction fraud check. So this is the real time data and we are processing it instantly. Okay, so it is used for live dashboarding, dynamic pricing detection, fraud detection, etc. And the third type of data set based on time is streaming data. So streaming data is a continuous non-stop flow of high volume data that is generated at high speed from thousands of concurrent endpoints. For example, continuous reading from IoT sensors, or there is live GPS tracking. If we talk about format, based on format, the data types are divided into two parts, that is qualitative and quantitative. So this is important to understand. So if we talk about qualitative, it is about talking about quality, right? So this is non-numeric data, it is text heavy, and it is focused on the quality and characteristics of the particular things. For example, we are performing detailed customer product review, we are we are analyzing interview transcript or sentiment analysis of the user tweets, right? And if we talk about quantitative data set, it is the numeric data. It is highly measurable data that you can perform mathematical calculations on, like monthly sales revenue, what is the customer's age, what is the total number of transactions, that is the quality. Now let's move to sampling distribution. So this is one of the most important concept in statistics, because in real life we rarely have access to entire population. Imagine trying to collect information from every customer of Amazon, or every voter in India, or every employee in a multinational company. It would be extremely costly and time consuming and sometimes impossible. So instead what we do, we collect the data from small group. All right, so we collect the data from the small group called sample and use it to make the conclusion about whole population. All right, so this is what sampling is. So we create sample out of population. So then what is sampling distribution? So one sample may not perfectly represent the population. So what statisticians do, they imagine taking thousands of different samples of same sample size. For example, sample of 10 number of values are there, so they are taking same size sample from the population and they are taking multiple samples, and for each sample they calculate the same sample mean. So there are, for example, 5 samples and we are calculating mean from each 5 samples. So there are 10 values in this, so its sample mean would be 2, and it's 5, it's 3, it's 4, and then they calculate the mean. So this distribution formed by all the sample mean is called sampling distribution. Alright, so when you put this distribution on a graph, that is sampling distribution. For example, sample mean of S1 is 48, of second is 51, of third is 49, of fourth is 50. Alright, so visualize it. So these are the sample mean. So if we continue taking thousands of sample and plot their mean, we get a new distribution which is known as sampling distribution of mean. Alright, I hope you are able to understand. So why do we need sampling distribution? Why is it important? So sampling distribution act as a bridge between sample data and population information. So it helps us estimate unknown population values and measure their reliability of our estimate. Alright, because we cannot study the entire population, we usually take one sample. but one sample can slightly have different result than other. That is why we use sampling distribution, having multiple samples and then calculating their mean and then visualizing that. Alright, so this helps us to measure the variation between the samples, okay, how much they are varying from each other, and estimate how close sample results are to the population value. So the population is the entire data set. Alright, and the mean of entire data set is known as population mean. It is represented as mu, mu. Alright, so it helps to estimate that how close our sample result is from the population mean, and then it makes the confidence based decision. Alright, that is why we need sampling distribution in statistics. Let's understand what are the key characteristics. First is that it is centered around the mean population. Now let's move forward and talk about the key characteristics. So first we have centered around population mean. This is the very fascinating property that an average of all sample mean, alright, sample mean is equal to the actual population mean, that is mu. Alright, so this means that sample mean is unbiased. Sample mean is unbiased and estimator of population mean. So what is the sample mean? How we represent the expected value of sample mean is equal to expected value of sample mean is equal to population mean. This is how you represent, this is how you write this characteristic, that sample mean is equal to the actual population mean. And then we have second property, that it is exactly like a bell shaped curve. It create a normal bell shaped curve. Alright, so why do we say that it has a bell shaped representation? Because most sample means are clustered near the center, okay, while the extreme value are increasingly rare. You see in this we have a bell shaped curve, right? So most of the mean population is around the center and there are extreme values are very less. That is why we create a bell shaped curve in this. Then we have less variation with larger sample mean. So the larger the sample size, the more accurate and reliable the estimates are. So if there is small sample size, then there is more variability, but if there is larger samples, then there is less variability. Alright, then we have another characteristic that says the spread is measured by standard error. So you need to know this term standard error. It is denoted by SE. So standard error measures how much the sample mean fluctuate from one sample to another. So for example, one sample mean is 5, other is 10. So how much is the fluctuation? There is 5 point fluctuation between those. So the standard error calculates the fluctuation between one sample to another. So it tells us what is the variability, expected variability of sample estimate. So it is calculated as standard error is equal to standard deviation divided by number of values. Alright, so this is the sample size and this is the standard deviation, SD, standard deviation. Alright, so what is standard deviation? So for example, there is an average, this is the line which is the mean, and if we visualize the point, that these are for example the points. So what is the difference of every point from the line? This difference is the standard deviation. So how much are the points deviating, distancing from the actual average? That is what standard deviation is. I hope you understood this concept. Alright, now quickly let's move forward and discuss what is sampling distribution with an real world example. Alright, so like I already told you that what sampling distribution is. So for example, you have a company named ABC, right? And this company has 10,000 employees. All right, now what are we trying to come in here? Say that this is the population mean. So whatever the mean of 10,000 employee, that will be the population mean. So now we created different samples. So let's say we created the sample of 50 each employee as a sample 1. So there's sample 1 with 50 employees, sample 2 with 50, sample 3 with 50, and we came out with the average of these employees, right? And then we visualize the mean. So what from our analysis come that this is the sampling distribution. All right, so we saw that most of the sample are distributed among the average 5. So this is how we are able to understand that this is the sample distribution average, and from the employees we'll get the population mean average, and we'll be able to relate that both of them are same. All right, so this is how sampling distribution works. Once we understand the normal distribution of a sample, we can use control limit theory to keep the business processes stable. Alright, so what is the core concept? So the control limit theory is a statistical concept that is used to determine whether the process is stable, whether the process is in control or it is out of control, by comparing the observed data with predefined statistical limits. So basically we apply limits to our data. So once the data point crosses that limit, that means that our data points are unstable, they are out of control, and once they are inside that limit, that means they are in control. So why do we need control limit theory? So every process shows some variation, like machines, human behavior, customer demand. There are variations in the behavior. So the key question is this variation expected or there is something wrong? So to answer that, we use control limits to understand the behavior and identify if it was expected or unexpected. So you see, in control limits we have 3 major lines. Alright, so first is the central line. So central line represents the long term running process average. So you see here dashed black line. So this is the average, this is the central line. Then we have upper control limit. So this is the upper acceptable boundary. This is the upper control limit. And then we have lower acceptable boundary, LCL, which is at the lower. Okay, so if the data point lies within limit, that means the process is in control. So you see these are within limits, and if it is the outside the limit, then the process is outside the control. Like you can see this data point, right? So how are these control limits set? So control limits are usually set at ±3 standard deviation from the mean. Why? Because about 99.73% of the value fall within this ±3 standard deviation of the normal curve, and the value outside this range are statistically lower. Okay, so they are rare. That is why there is a formula to calculate the upper control limit, that is mean plus 3 into standard deviation. For lower control limit, we have mean minus 3 into standard deviation. Alright, so we are keeping the gap of into 3 times the standard deviation. For example, this is the standard deviation. Standard deviation into 3, this would be the upper limit, and minus into 3 would be the lower limit. So we are giving them enough area that this is the identified area that the process is in control, right? And after this area, after this limit, if any process is falling outside the limit, then that means that they are not in control. All right, so let's understand this with an example. So there is, suppose the population of student has an average height of 156 centimeter with the standard deviation of 10 centimeter. All right, so average height, population mean is 156 and standard deviation is 10 centimeter. All right, so if we draw samples, we draw sample of for example 50 each. So what happens? Now we calculate the sample 1. So sample 1 are 50 student. For example, their mean is 154 centimeter. Alright, so how are we coming from this? First, we'll calculate the standard error. Standard error, like I told you, it is calculated by standard deviation upon the number of population size, which is 50. So we come up with 1.41 as a standard error. Right, now this is what we'll put in the formula. So first we have 165, right? So 165 minus 3 into 1.41. This is, we are calculating the lower limit, right? So 165 minus 3 into, so you see what is the formula of lower limit? 3 into 1.41, right? And then we'll calculate the upper limit, which says upper limit, which is mean is 165 plus 3 into what is the standard error? 1.41. This is how we calculate the upper control limit, right? So if sample average shows up as 175 centimeter, then you instantly know that it is an anomaly, something unusual. Why? Because when you calculate the lower control limit, it comes out to be 160.77, and if you calculate the upper limit, it comes to be 169.23 centimeters. So if you see any value which is 175, you can clearly say that it is an anomaly. It is something unusual is happening, because it is also crossing the upper and lower control limit both, right? So I hope you understood this concept, how we are working. So this is what exactly is working of sampling distribution and control limit theory. So if you look at this picture, you see from our analysis, this is the population mean, and this are the upper and the lower control limits which we have calculated, because the standard error was 1.41. So our sample mean is normal. So most sample mean fall between 163.6 and 166.4 centimeter. So the spread, the standard error is 1.41, right? So before we clean the data, we must know what type of matter we are dealing with. So let's break down what are the data elements. So data elements are the basic unit of information within the data set. Alright, so data element, you can say it is the smallest indivisible unit of data that holds a specific meaning. For example, you have table, you have fields, you have rows, and you take this particular cell. This is a data element. Alright, so they are fundamental building blocks of the data set, right? They make up a data set. They are varied in nature. They can represent wide variety of information. They can be numeric value, they can be complex text, or they can be coordinates. They can be longitude and latitude as well. And if we talk about types of data element, we'll discuss that. So first we have categorical data elements. So they represent distinct categories or groups, right? So these represent labels, characters, group, and the categories have no inherent ranking or order. So they are nominal and ordinal. So these are two types of category. Nominal is category without inherent order or ranking. So there is no particular ranking. And ordinal is the type of data set in which the categories have meaningful ranking. For example, you see you have standard scoring A, B, C, D. So A is for excellent, B is for very good, C is for not good, and D is like okay, average. So this is the ranking system. But for example, you have student ID 2014, 2066. So this is like, they don't have a clear hierarchy in this. You are just uniquely identifying any student, so you're providing any ID, right? Alright, so note this, that machine learning algorithm can't read text directly, so we map these categorical format to numeric representation. All right, so there is mapping happening. So you see there is a ranking A, B, C, D, E, and we give it a particular numeric format, and then we put it into the machine learning. All right, so let's move forward to second type of data element, that is numeric data element. So if we talk about numeric data element, we have further two types, discrete and continuous. Right. So discrete data element are countable values that cannot be broken into fractions. For example, we say 5 kids. Right. We say 3 laptops. We say 96 worker. So you cannot have 3.5 laptop. You cannot have 5.5 kids. There is no, you cannot break them into fractions, right? And on the contrary, we have continuous data, which are measurable values that form an unbroken infinite range and can contain decimals. Like you can say your weight is 35.5 kgs, so you can have decimals, and it can be stored in fractions as well, right? So these are the kind of data elements we usually see in our data set. If you have a look on real databases, you will find empty cells everywhere, and they are donated by nan, which means not a number, or null, right? And if ignored, they ruin everything. Alright, so addressing the missing values in our data set is very important step to ensure that our results are reliable. And if we don't handle these missing value, it can lead to flawed insights. It can lead to erroneous decision making, which is not any organization expecting, right? So that is why we need to have accurate insights, because accurate insights are bedrock for decision making, right? And handling missing value directly influence the accuracy of our analysis. So by acknowledging and appropriately managing the missing value, we actually create more meaningful and actionable conclusion. And if we talk about what are the impact of this missing value to the result, then first is biased sample representation. So if a certain subgroup consistently fail to fill out a field, your remaining data stop representing the real world fairly. For example, if we talk about most males are not filling their salary, and most females in our survey are not filling up their age, that means you are consistently missing out all the required data, and there can be bias in terms of salary for men and age in terms of female, right? So this can lead to inaccurate results. Second, it can lead to reduce statistical power. So when we have empty spaces in our data set, it reduces the active sample size, making harder to test and find the true patterns in our database, to read the behaviors in our database. So still it would lead to inaccurate insights. And also it can impact in selection bias and in imputation methods as well. So blindly guessing values can introduce massive synthetic bias as well, right? And that is why we use imputation methods to fill out missing values. However, the choice of imputation, what you are filling instead of the missing value, can also influence the result. If the imputation, if the missing value, if we fill out any value instead of the empty value, it will also affect our analysis, right? So it is very important that we always analyze and put the right method to handle the missing values. So guys, missing data falls into 3 distinct mathematical categories, which you once know before you actually choose to fixing the missing values, right? So there are 3 types. There is missing at random, then there is missing completely at random, and missing not at random. So first we'll talk about MCAR, which means missing completely at the random. So the missingness over here, missingness of the data, is purely an accident. So the probability of data missing is completely identical for every single row and has zero correlation. Okay, there is zero correlation with any other data. For example, a lab assistant accidentally drops a test tube, spilling the random blood samples, or a wireless network glitch drops a single sensor data packet. Alright, for example. So these examples are actually that we are missing the data at accident. Alright, so what are the implication? We can the missing value are unrelated to both observed and unobserved data. So we can handle these values straightforwardly, like using list-wise deletion or imputation methods can be applied without introducing bias. Right, then we have MAR, which stands for missing at random. So the missing value isn't purely random, but its missingness can be entirely explained by another variable that is visible in the dataset. For example, there is a survey which track weight across gender. We are tracking weights. So wherever there are no gender specified, we are less likely to write down the weight. For example, females or with no gender, they are not writing the weights. Alright, and if there are the category of male, they are writing the weight. So you see the missing values are behaving randomly and within the recorded group only. Right, so this is missing at randomness. And then we have missing not at random. So this is the most dangerous type of missingness. So the reason the data is missing is directly tied to the unobserved value itself. So for example, people with exceptionally high income purposefully leave the salary field blank on the survey out of privacy, and low performing students skip, for example, another example that low performing students skip the course feedback form. Right, so here we cannot relate it to any data. So this data in which they are, why they are doing this is unobserved. Right, so like we have discussed about three types of missing data. Now let's understand it by seeing this diagram. So if you talk about missing at completely random, you would see we have x variable which we can call as independent variable, and y is as a dependent variable. So this is the outcome. And then there is m, which stands for missingness. So whether the data is missing, which is m, and c is the other observed variable. Mostly it is covariates or control variable. Okay, so dependent, independent, missing data, and other variable. And these arrows are showing the correlation. So if we talk about missing completely at random, so here we see that x affects the y. So x is an independent variable, it affects dependent variable, and it affects the y, right? And y may and c may affect x and y both. So this is a covariate. It might affect both of the variables which are present in the data. And m, which is the missing data, it is not related to any one of them. Right, it is not connected to either x or y or c. This means that the missing is independent of all the variables. Right, so if it can be ignored, yes, it can be ignored, and usually there is no special correction which is needed. Expect we can have list-wide deletion or preserve the sample size through simple imputation. Alright, then we have missing at random. In this, you notice that c influences x, right? And missingness is related to either x or c. So the missing data is either related to the variable x or c, right? And missingness is not directly related to unobserved value y. So this is an unobserved value, it is not related to that. Alright, so you see we have age and income. So age 20 missing, income 25 missing, income 60 age we have income. So income is missing because of the age, so we already know why it is missing, right? We have that variable. So generally, can it be ignored? Generally yes, if modeled correctly. So we can use appropriate multiple imputation, maximum likelihood method, or appropriate control methods. Then we have missing not at random. All right, so in this you say that missing value is directly related to either x or c or y value as well. So it is also, it might be related with the unobserved value as well. So missingness depends on the value that is missing. All right, for example, income 20,000, income 30,000, and missing, we have a missing value which is actually 5 lakhs, and this value is missing because high income individual intentionally skip the question in the survey. So can it be ignored? No, it is non-ignorable because it is causing biased results. Because we don't have salary from the higher income earning people, then how will we able to actually define whatever our model is able to define, right? So we use here multiple imputation methods, right? We use extra assumption, Bayesian techniques, sensitivity analysis, etc. So the very first step while cleaning the data is identifying where the missing values are. And the next step, the second step, is deciding how to treat them. So there are few techniques to identify the missing values, right? So very first is the descriptive statistics. So we use basic descriptive strategy. This is the simplest way to detect missing data while counting how many valid entries exist in the column. So if a column has fewer observation than expecting, then we know that the data is missing, right? So this provides us a quick summary and tells us where we need attention, right? So if columns with a very high percentage of missing values, then that column might be unreliable for us, and sometimes we need to remove it entirely, right? That is why we use descriptive statistic. Second, we have the method of visual inspection. So what does visual inspection mean? That we are visualizing the data, right? So counts which we are counting in descriptive statistics are useful, but visual tool often reveal the patterns that numbers hide, right? So a missing value like heat map or matrix display, right? Heat map or matrix display displays every cell in a data set using color. So the present values appear in one color while the missing values appear in another. So we are visually able to analyze that if data is present or not, right? So you see, we have visualization tools which play a very key role in uncovering the patterns and trends in missing data, right? And these insights, these visualization provide us insight into what is the structure and what is the distribution of missing values, right? So we have heat maps. So heat maps are like color coded kind of visualization tool in which there are darker shades to represent the higher proportion of missing data, and then there are lighter shades where we have already data, right? So it is a very reliable tool in which we can clearly identify how data is distributed. Then we have missing value matrix, which display a matrix where missing values are marked, right, making it easy to spot the patterns. So each cell represents a variable and missing values are highlighted in that matrix. Then we also have bar charts. So we create bar chart to visualize the percent of missing value for each variable, right? We have bar chart and we see student ID missing percentage, for name missing percentage, for class missing percentage, and we can identify which of the variable has high proportion of missing data and take actions accordingly. All right, and then we also have programming techniques. So in practice, data scientists usually identify missing value programmatically. That means they use either some of the programming languages like Python, Pandas. So it is a common approach. Python Pandas library is a common approach to check each column for null values. All right, so we use is null function in Python to identify if there are any missing values or not. So this gives us a clean reproducible summary that can be automated in data pipelines, and it is especially important when working with large data sets containing hundreds of columns. Alright, so this is how we identify our missing values. Now we'll talk about imputation methods, how to fill the gap. So once we have identified, we need to decide that how we handle them. So process of replacing missing entries with estimated value is known as imputation. When we replace it with something, right, so we are imputing. So the goal is not to invent the perfect data, it is to make reasonable estimate while preserving as much information as possible, right? So you see, there is no single method that is best, right? So the right technique depends on the type of data. It depends on what is the amount of missingness and what is the underlying business problem. So it is very important to identify all these key areas, and then we choose our method of imputation. So the very first method is median mode imputation. This is the very common beginner level technique in which we are replacing values with either mean, either median, or mode of the available data, right? So when we use mean is used when the numeric data and we have a roughly symmetric distribution. All right, so it is a symmetric distribution, then we use mean. We use median when the numeric data has outliers, then we choose median imputation. And we choose mode imputation when the categorical data, right, we have categorical data. For example, we have text data, example the color name. So then we use the mode, so which is the most occurring one, and we impute the missing value with that particular value. All right, so next is the forward and backward fill. Okay, so this imputation method is used for sequential data such as stock prices or sensor reading or daily sales, in which we often use this method. So what we are doing, we are propagating the last known value forward or the next known value backward to the missing field. So we are just looking at what is the value above us or what is the value down us, and the next available value is copied backward or it is copied forward. Okay, so these methods are useful when neighboring observations are expected to be similar, especially in time series data, right? So you know that next would be this particular time, right? So they are appropriate when values change rapidly or unpredictably. Then comes the other method, which is interpolation method. So interpolation estimates a missing value by looking at the value around it and assuming its smooth trend. All right, so they're just assuming, okay, based on the relationship of the known data points, we just look at what might be the estimation. So it is applicable when the data exhibit a certain level of continuity, right? So for example, day 1 the value is 10, day 2 the value is missing, and day 3 the value is 14. So you see 10 and 14, so we assume by linear interpolation that this day 2 would approximately 12. So this assumption is what interpolation is. So interpolation assume the missing point which lies along the reasonable trend. So if the data is highly erratic, then interpolation may produce misleading estimate. That is why it is very important to analyze what method we are using. Alright, so what are the advanced imputation method? Let's just have a quick look on these. So we can also have multiple imputation, which generates multiple data set with imputed value to account for uncertainty of missing data. Alright, so when we have complex data set where imputation uncertainty needs to be considered, in that scenario we produce multiple data sets. Then we have predictive modeling. We are using machine learning algorithms to predict what are the missing values based on other variables in the data set. And we can also use a machine learning algorithm which is k nearest neighbor imputation, in which we are imputing values by considering what are the value of the nearest neighbors. So for example, there are multiple data points, right? and there is one data point whose value is missing. So we'll identify, for example, 3 neighbors, and according to these neighbors we will assume the value for the particular data set, right? So it is suitable for the data set where similarity between the data point is meaningful, right? And there are symmetric systematic data, and there is a meaningful relationship among the nearest data points, right? I hope you understood this concept. So let's quickly shift our focus to outlier. So an outlier is a data point that deviates significantly from the rest of the pack. So there are anomalies, there are extreme values, or weird experimental errors. So all these are regarded as outliers. So think of them as the rebels of your data set, and they just refuse to follow the rules that everyone is living by. So I'll give you an example. Imagine you are sitting in a local coffee shop, right? So you are sitting in a local coffee shop with 9 other regular people. Okay, so the average net worth of the room might be say 12 lakhs per annum. All right, this is the average. So suddenly Bill Gates walk through the door and sit down. So if you recalculate the average net worth of the people in that room now, everybody is suddenly a billionaire on paper, right? So Bill Gates is an ultimate outlier, right? He hasn't actually made anyone else richer, but his presence completely distort the reality of the room. So that is how outliers work, right? So they are the observation that are marked different from the majority of data points, and they deviate significantly from the data set. Okay, so they can be unusually high or unusually low to the rest of the data set, and they are also regarded as anomalies or extreme values. So you see, this is an outlier. These are the normal data set point, and you see one extreme value, right? So now outliers come in two distinct flavors. So one is univariate, then second is multivariate, right? So understanding the difference prevent you from missing the stealthier ones. All right, so the univariate means this is an extreme value in a single isolated column. So it sticks out like a sore thumb all by itself. So you see over here, this is a univariate outlier. So imagine a human height entry in a medical database reading as 350 centimeter. So about 11.5 feet. So you don't need to look at any other information to know that this is impossible. It's an error, all right, or a massive anomaly just by looking at that one column. And then we have multivariate. So multivariate means multiple column combination. So this is an unusual combination of values across 2 or more columns that wouldn't normally coexist. So individually the numbers are perfect, right? But together, if you look, they look absurd. So imagine a row in your data set for a person who is 5 years old, right? And their monthly income is listed as $50,000. So if you look at the age of the column by itself, 5 is normal, and if you look at the income column by itself, it is 50,000 is normal. It is a normal corporate salary. But a 5-year-old making $1 million a year, unless they are global movie star, you have caught a multivariate outlier, because there are multiple columns in together forming an outlier. I hope you understood this concept. So why do we care so much about outliers? Because leaving outlier untreated is dangerous. They have devastating domino-like impact on your entire analysis. So it can skew the central tendency. So you see, it gives the misleading representation of data by shifting the average, by shifting the central tendency. Alright, it can also affect the dispersion. Example, imagine checking in the weather for a week. It's like 22 degrees Celsius, 23 degrees Celsius, and then due to a sensor glitch, it records 110 degrees Celsius. Suddenly your data says the temperature varies widely by nearly 90 degrees, which is clearly impossible. So it artificially expand your standard deviation, right? Standard deviation and range. making your stable data look incredibly chaotic. And it can also distort the relationship. All right, it can distort the correlations and regression analysis, which can lead to inaccurate insights about the relation among the data. And it also can have an influence on predictive models, right? If we feed out a wrong data, so there is garbage in, garbage out ideology, that it will lead to inaccurate predictions, and the quality of decision making is then also affected by the outliers. That is why it is very important to detect the outliers. So how do we catch these troublemakers? We use three main approaches: visual, statistical, and machine learning methods. So first we use visual inspection. So there are multiple visualizations which are purely used to identify these anomalies, right? So we have scatter plot. Scatter plot, what it do, it provides a relationship between the two variables, allowing the identification of data points which are not in that particular crowd. All right, so scatter plots are like a map of crowded concert. There are multiple data points and everyone is packed near the stage, right? So a scatter plot instantly shows a couple of lone dots which are floating out upside somewhere in the empty space by themselves, right? For example, in a concert, few people are just standing in front of the exit gates away from the main cluster trend line. So we can easily spot the outliers in a scatter plot. Then we also have box plot. So box plot play a very vital role. It clearly defines us what is the what is the mean, what is the median, and it provides us the IQR, which is the interquartile range. And then we also have the IQR range, and after that IQR range, whatever data points are existing are known as outliers. All right, so it displays data quartile. Think of a box plot as a fenced yard. So the fence represents the normal boundaries of the data, and any data point sitting further than this IQR, which is 1.5 into whatever the IQR is, past these outer edges, whatever is standing, it is an outlier dot. For example, there is a stray animal that escaped your yard, so that is now an outlier, right? And we also have histogram, which we can use to visually see that if there is a particular value which is completely deviated from other data set, so we can clearly see that there is an outlier. All right, so second method is using descriptive statistics. So descriptive statistics, by using mean, median, right, standard deviation, quartile, we can identify the data points that fall outside the expected range. So what are the advantages? That it provides numerical summary of the data, right? So it can helps us identify the extreme value. So descriptive statistics use two methods. First is z-score method. All right, so this measures exactly how many standard deviation a point sits away from a mean. Okay, so how much the point is sitting away from the mean. I hope you understood. So this is the formula of z-score, where z is equal to, this is the mean of the data point minus mu upon the standard deviation. All right, so if the z-score is 0, that means it is exactly at the mean. If z-score is greater than 0, that means it is above the mean. If z-score is less than 0, that means it is below the mean. And if the z-score is greater than 3, it is commonly marked as an outlier, right? So think of z-score as a social distancing rule for data. So if the average distance from the center is 1 meter and someone is standing 4 meters away, that means they are breaking the rule and they get flagged. All right, so this is the concept of z-score. Then we have IQR method. It is called interquartile range, and it is used in the box plot as well, which we saw in visualization. So this focuses on the middle 50% of your data. Alright, and it calculates the distance between the 75th percentile, which is quarter 3, and 25th percentile, which is quarter 1, and center is the quarter 2, which is your mean. Alright, and after this we have the interquartile range. So this range, it is minus 1.5 into IQR. Alright, and this is the lower bound, and similarly 1.5 into IQR, this is the upper bound. So these value are that in this particular area also data point can lie. So these are the bound, this is the fence, more area. But outside this area, anything outside this area is an outlier. Alright, next we have is the machine learning methods as well. So by using various machine learning algorithms, we can identify the patterns and anomalies in our data set, right? So we can use machine learning algorithm like isolation forest. Then we have support vector machine clustering algorithms for outlier detection. Once we find the outliers, we can't just panic and delete everything, right? We have to be surgical. We have 4 primary treatments depending upon the situation. First is removal. We can simply delete the outlier record, right? So for example, there is an outlier in a row and we delete that row completely. So the thumb rule is that you only do this if you are 100% sure that it is a data entry typo or a system error. So if someone typed the weight, for example, 5000 kgs instead of 50 kgs, so you wipe it out, right? Just be careful that deleting the real data, because it is surprisingly, it is a cheating when we delete the data. All right. Then we have transformation, right? So what we do, we apply log, square root, or Box-Cox transformation to reduce the impact. Alright, so we use logarithmic transformation over here. So think of it like looking at a skyscraper through a magnifying glass. Okay, and it is flipped backwards. So what you see, it squishes the scale to an extreme value down, minimizing the mathematical pulling power so that don't break your model, right? So we are minimize the impact of outliers by using transformation techniques. Then we have caping. Okay, so what is capping? It is setting a strict threshold. So think of a parent setting a volume limit to the kid's iPad, that you cannot higher up your volume more than this. So if the kid can turn it up to 100, but the software cap which is applied to that, the actual sound output is only at 80. All right. So if your 99th percentile for income is $150,000, any value above that or even a multimillionaire is automatically changed back down to this only, 150,000 only. Alright, so basically we are providing an end value that this is the cap, and above that we are not accepting anything. Alright, so it is like a ceiling and the floor. Then we have imputation method, which we have already talked about in missing value as well, that we erase the outlier and predict a realistic value. For example, treat the outlier like a smudge or on a painting. So you have a good painting and you have a little smudge over there. You carefully scrape away the bad spot, right? And look at the colors, the pattern and the surrounding pixel using the algorithm like KNN, and paint over with structurally sound replacement and fit the context perfectly. So what we are doing, we are using few imputation methods like imputing the value with mean, mode, or any other imputation method to erase the outlier and make the data more reliable. And we can also treat the outlier as separate group. This is called as segmentation, which we'll discuss forward. So what we are doing, if there are multiple outliers, sometimes these outliers are not actually anomalies, they are actual data, right? When we talk about Bill Gates, one example, so Bill Gates is actual data which is entering in the coffee shop as well, right? So if we drastically remove it, so it might impact our data set, but we can treat it as a different value, right? Different separate group. So this we do, we divide the data into different segments, right? So for example, we have VIP customers, so they have different segments. We have fraud cases, it can have different segments. So it preserves the rare data and allow the targeted analysis as well, and we do not lose the essential data set as well. So let's now talk about what is standardization. Alright, so data standardization is a process of transforming data into a common format. Alright, so what it does, it ensures that different data set which may have varying unit, varying ranges can be compared and analyzed efficiently. Alright, let's understand with an example of an apple and an elephant. Alright, so I don't know how to, okay, I can draw it. So if you are talking about an apple and an elephant, alright, so imagine you are a judge at a competition and you are asked to score two things. So you are scoring the weight of an apple, alright, and weight of an baby elephant. So the apple weighs 200 grams, okay, and the baby elephant weighs 200 kilograms. But if you just look at the raw number 200, it is 200 versus 200, right? Your computer thinks they are exactly the same size. But if the apple gains 50 grams, if it gains 50 grams more, that is massive. Oh my god, giant apple. And if the elephant gains 50 gram of weight, then it is completely unnoticeable, right? So standardization is like converting both of them into the scale of uniqueness. Why? So that the algorithm understand that a heavy apple is as significant in its own world as the heavy elephant, and they both have completely different weight measurement. The number is same, but the scale of measurement is completely different. So if our computer is analyzing them as same thing, then it is a biggest mistake. That is why we need to standardize how we are keeping our data, right? So first we have is min max scaling, and we also called it as normalization, right? So it is a core its core mechanic is simple. It takes your numeric data and forcefully squishes it into a fixed rigid range. Like for example, you are typically bounding your range between 0 and 1. So every data set would be converted into this. So the absolute smallest number in your data set becomes 0, and the absolute largest number between your data set would be 1. So everything falls somewhere in between, right? In between the 0 and 1. Alright, so the goal is to standardize a range of independent variable or features of the data, making them comparable and preventing the issues caused by different units or scale. Like we talk about apple and elephant, right? So if there are different units or scale, we can quickly overcome the problem by using min max scaling or normalization, right? So this is the formula for normalization. So how we calculate it? By the x is the original value of the data point, x minus the x min. So this is the minimum value of the data set, and then x max, which is the maximum value of feature in the data set, minus the x min. And this is how we get the scaled value, the new value. Alright, and this new value is now treated as a data cell in our column, in our data set, right? So first we identify what is the minimum value and what is the maximum value. Alright, after identifying that, we first calculate the total range, that is max minus min, and after that we calculate the actual value minus the min, and we divide that. Alright, if you see this example, we have original features like this is our data 2, 5, 8, 10, 15. Alright, so you see the minimum value is 2 and the maximum value is 15. So first we'll calculate what is the max minus min. Alright, so it comes to be max minus min, 15 minus 2 is 13, right? And we then calculate every item above that. So 2 minus 2, which is 2 is the original value, and minimum value is 2 minus 15 minus 2. All right, and it comes out to be 0. So we will scale every value. We will create new data set value for this value. So these are the scaled features after calculation. Alright, so these were the original feature you see between the scale of 2 to 14. Over here you see the scale 0 and 1, and these are the scaled variables, same as these. So it is very easy to then convert the data in normalization form and use it, and in this you will see that the relative differences and trend between your data point remain exactly the same. The trend is exactly the same between the data set. The shape of the data does not distort. We just simply shrunk the vertical axis, right? We have simply shrunk that, and it is perfectly locked between 0 and 1. So the second approach is Z-score standardization, and it is also known as standard scaler in our libraries. When we code, right? So we see this as a standard scaler. So instead of forcing the data into rigid box of 0 to 1, Z-score scaling does something different. What it does, it shifts the data so that the new mean, so the mean turns into 0 and the standard deviation turns exactly to 1. This is what it does. Alright, so this is the exact formula of Z-score, which is mean minus standard deviation. The actual examined data point minus the mean upon standard deviation. So this is the formula of Z-score. So Z-score is used to transform the data set into standard normal distribution with mean 0 and standard deviation 1. Alright, and it is useful for comparing and analyzing data points that may have different scales. So we have two methods, either we use Z-score, alright, or we use normalization. So let's understand this with an example. So we have original data of 10 to 50. We have these value. First we calculate the mean. Mean tends to be 30. And if we calculate standard deviation, it is tend to be 15.81 approximately. Alright. And now we apply the Z-score formula. To applying the Z-score formula, you see, we apply it to every element. We apply it to 10, 20, 30, 40, 50. And after calculation, we come out with an particular data point which is scaled, right? And you see, these is the normalized data point according to that. So what was happening? This was our original values from 10 to 50. This was our original value. When you see our Z-score normalized value, it is between -1 to 1. So our mean is exactly 0 and our standard deviation is exactly 1. Alright, so here if you see it is 1, here you see it is 1. So the deviation from the mean is exactly 1. So this is what Z-score does. Alright, if you see the basic difference between the both of the types, first is standard deviation, standard scaler, which is Z-score. It transforms the data so that mean is 0 and deviation is 1. Whereas min-max scaler transforms the data into fixed range. So the data must lie between 0 to 1 only. Right? So they have different formulas, absolutely. And the use of standard scaler is that we have mean and standard deviation. And here the uses are of minimum and maximum value. So the output range has no fixed limit, right? It can be from -infinity to +infinity. Whereas in min-max scaler, we have the fixed range. And it is the effect on data is that data centers around 0. Whereas here we compress the data into small interval, right? It can be from 0 to 1. So this is an interval in which we are dividing the data. Alright guys, in the real world, raw data arrives as a massive chaotic flood. Categorization is the formal process of organizing, alright, it is the formal process of organizing the data and grouping the data into specific groups, into specific classes based on the predefined criteria. So the main goal here is to transform the overwhelming ocean of rows into organized buckets to make analysis humanly possible. All right, so think of it like a walking into a massive library. So without categorization, books would just be thrown into a single giant mountain on the floor. That is why we need categorization. So there are various types of categorization. First, we have hierarchical structure. All right, so when we categorize the data, we generally see that data nested inside the layers, where each layer is subcomponent of the above layer. So there is a parent child tree concept, that there is first layer, then we have sub layers. All right, and then we have sub layers of the sub layers. So this is a hierarchical data set. For example, a spatial or geographical hierarchy. You see in that scenario, your data travels down from continent to country to state to city to town, right? So you can't talk about specific street without referring to the city, which is inside the state, which is inside the country. So it creates a neat structured path down the data tree. So that is the hierarchical structure. That is data classification, categorization. And then we have numerical ranges as well. So the chopping block. So this is what is when data classified based on numerical ranges to create intervals. Okay, so taking an endless continuous stream of numbers and chopping it into distinct buckets. All right, this is what numerical ranges means. This is what binding means. So for example, instead of forcing a machine learning model to analyze every single individual, like individual age, like 8, 16, 35, 72, what we do, we bin them. All right, we bin them in the categories like child, okay, then another category teen, then another category adult, and then we have senior. So we are binding them. So this is incredibly helpful when building decision trees or plotting histograms, because it simplifies all the complex pattern, and analyzing every single individual age would be very complicated, right? So we bind them into life stages. That is what binding is. That is what chopping the data looks like. Then we also have dimension categorization. So in this we are performing categorical dimensions. So we are sorting the operational inventory items, products or records by specific or hard attributes. All right, so what is happening in this? For example, think of an e-commerce platform like Amazon, and it handles the inventory, and it automatically catalog every product by its types, right? So we have catalog for types, we have for brand, we have for price range. So what it does, it allows database to instantly slice and filter the product, right? So if we ask for a range, so it filters all the product, all the brand, all the category in that particular range only. So that is how categorical dimension works. So we are assigning data points to specific category within the dimension only. All right, and next we have temporal categories. This is like a time slicer. So it is slicing the data based on standardized chronological brackets to run the time series trend analysis. For example, we are grouping the daily chaotic financial transaction into a clean bucket like days, all right, like months and quarters, and then financial year. So this is how business can look back and spot where the seasonal trends lie, and then notice that sales always skyrocket in quarter 4, because it is where the Diwali season is rather than quarter 1 or quarter 2, right? So they're able to identify those trends. So that is only possible by temporal categorization, the time slicer. Now, a lot of people get confused and think that categorization and segmentation are exactly the same thing. So let's clear that up for now. So I'll tell you what segmentation is. We have already discussed about categorization, and you will create a tabular difference between the both after this discussion, right? So while categorization groups data point conceptually to organize them, segmentation divides the entire data set. All right, it divides the entire data set into operational subset, based on the shared characteristics to drive specific targeted business action. So categorization was about the sorting the data, right? And segmentation is about taking action, okay? Or you can say it is about acting on the data. For example, we have imagine you run a massive hotel. Okay, you run a massive hotel and sorting all the uniforms in the laundry room by sizes. Like you have small sizes, you have medium sizes, and you have large sizes. This is categorization. You are organizing the inventory, right? However, looking at your hotel guest and dividing them into business travels who need fast Wi-Fi and iron suit versus the couples who want to have champagne, right? This is what segmentation is. So you're grouping them so that you can deliver a completely tailored experience to maximize your revenue. That is what segmentation is. Alright, so it refers to the process of dividing the dataset into distinct subset, or we can say segment, based on certain criteria or characteristics, right? So the goal is to gain a deeper understanding of data and identify the pattern, trend, or insight within the segment. Alright, so what are the, so this approach helps us make more targeted and informed decision, and it allow analysts to focus on the specific group. Alright, have a targeted approach. So if we talk about the types of segmentation, it is clearly splitted into two major worlds. First is categorical segmentation. So this relies on qualitative attributes. This relies on qualitative attributes of the group profile together. So what we are doing over here in demographic segmentation, we are dividing data by human population based on the human population markers like age. We are dividing in gender, income, education. So we are creating these brackets. So example, we are targeting luxury car ads to the individuals who are making over 25 lakhs rupees. Okay, so we are just making the targeted advertisements for that particular segment of the data, right? Then we have geographic segmentation, in which we are segmenting by location matrices like neighborhood, city, or global economic regions, right? And then we have behavioral segmentation, where we are grouping the users by their specific actions. So this looks at the app engagement frequency, brand loyalty points, or past spending histories. And then we have quantitative segmentation. So this bypasses the human traits and divides the profile mathematically. Alright, we are using numerical ranges over here, strict numerical intervals, and precise time-based performance buckets. Example, we are separating servers into category based, whether their CPU usage is under 20% or between 20 to 80% or over 80%. So this is what we are giving them, a separate quantitative measures, right? And then if we talk about the advanced cluster analysis, so cluster analysis is the concept of using advanced statistical techniques to identify the natural grouping or clusters. So in traditional segmentation, you define the rules, like you define that a group of people over the age of 30. Okay, so you're defining the rule. But in cluster analysis, you take a step back. You use advanced techniques, advanced machine learning algorithms like k-means to automatically crawl across the dataset, discover hidden multidimensional patterns, and cluster highly similar data points together without any human interaction. For example, Spotify doesn't look at your age or country to recommend music. Its clustering algorithm look at thousands of behavior variables like tempo of songs you skip, or the time of the day you listen to the song, the blend of generations you like, and clusters you the exact micro segment, and which it says is the playlist for you guys, right? With thousands of other users globally who share the exact hyper specific taste. All right, that is how cluster analysis do? It is, for example, letting the AI or machine learning find the patterns within your data. So to visualize the segmentation, we use bar charts, pie charts, line graphs, heat maps, and can be applied. So these segmentation, you see, we are applying here the segments. We have created the segment based on particular behavior. We are using scatter plot over here to identify the segment among the data set. And using these visualization tool, we represent the characteristics of each segment visually. So guys, you're doing a great job. So last but not the least is the type of sampling distribution. We have already discussed what sampling distribution is, but let's just have an overview of what are the different types of sampling distribution. First, we have simple random sampling distribution. It is the most fundamental approach. In this method, every single individual in the population has absolutely equal chance of being chosen. So there is no bias, no grouping, no hidden strategy. It is pure unadulterated randomness. For example, when you create a sampling distribution using random samples, the CLT, the central limit theory, tells us that as long as your sample size is large enough, the distribution of the sample means will form a beautiful symmetric bell-shaped curve centered perfectly around the true population mean. Alright, so for example, there is a lottery drum. So imagine a massive lottery drum filled with 10,000 ping pong balls, right? Each representing a person in a city. So to conduct simple random sampling, you blindfold yourself, you spin the drum and pull out the 100 balls. Because every ball is identical and floating freely in the drum, so for example, ball number 42 has exact same mathematical probability of being selected like ball number 9099, right? So it is completely fair, but it has a flaw that if by pure random luck you happen to pull out an unusual number of high income or low income individual, your sample statistic might drift away from the actual average. So this is the flaw, right? And then there is a second type, which is stratified random sampling. So this is what we use when our population is diverse and contains distinct subgroups. So the subgroup is known as strata. Alright, and we want to ensure that every single subgroup is fairly and proportionally represented in our sample. So what we do in this, instead of leaving representation up to random chances like we did in the lottery drum, we take control. We divide the population into mutually exclusive groups based on the different characteristics. For example, based on age, based on gender, based on income. And then we draw the sample from each of these buckets, okay, from each of these individual groups. For example, if we talk about, imagine you have a giant tub of ice cream, which is perfectly divided into 3 equal layers. There is chocolate, vanilla and strawberry. So if you used simple random sampling with a giant spoon, you might accidentally scoop up mostly chocolate because it is where you shoved the spoon. To use stratified sampling, you recognize the layers, you recognize the strata. So you say, I want 3 ounce sample. So I'm going to carefully scoop exactly 1 ounce of chocolate, 1 ounce of vanilla and 1 ounce of strawberry. So by doing this, your sample perfectly mirrors the exact composition of entire tub. So in sampling distribution, stratified sampling dramatically reduce the variance, meaning your sample average will cluster much tighter, more accurately around the true population mean, because you have eliminated the risk of leaving a subgroup out, right? And then lastly, we have cluster sampling. So in cluster sampling, this is often confused with stratified sampling as well. So please pay a close attention. So in stratified sampling, we divided the people into group based on the characteristics, right? So a sample and a sample of few people from every group. But in cluster sampling, we divide the population into group based on the convenience, okay, or geography, called clusters. So we divide into clusters. So where each cluster is ideally a mini replica of whole population. And then we randomly select a few entire clusters and survey everyone inside them while completely ignoring the other cluster. So what is happening? Imagine a donut company manufactures 1,000 donuts per day and pack them into 100 boxes of 10 donuts each, right? And each box contain the random mix of glazed chocolate and jelly donuts, and you are the quality control inspector. If you need stratified sampling, you would have to open all 100 boxes and take one donut out of every single box, right? That takes way too much time and ruins all the packaging. So instead you use cluster sampling. So you treat the boxes as your clusters, all right, and you randomly pick 5 boxes out of 100. You open them up, you test every single donut inside the 5 boxes, and you assume that because each box represent the mini mix of the factory output, checking these entire cluster will give you an accurate picture of the whole batch. So this is what clustering is. And with that, we have officially completed our comprehensive deep dive into Unit 1 of Data Analytics and Visualization.